Hello children, hope you have gone through the video of PN junction diode in its forward biased. Now we will study about the PN junction diode in the reverse bias. So what is reverse biasing? We know the P side of the diode or the positive side of the diode is connected to the negative side of the external battery, and the negative side of the diode is connected to the positive side, or the positive side of the diode is connected to the lower potential, or the negative side of the diode is connected to the higher potential. So let us draw it. So we know that it's a PN junction. You already have watched the video of a PN junction diode in its forward biased, and we have studied what happens to the potential barrier, what happens to the depletion region, like that. So here there is a depletion region here, and the the acceptor atoms in the P region, which are negative with the holes here, and the the donor atoms here, which are with the electrons here. Here there are holes, the majority carriers, but they cannot cross as the diode is not biased. These things all you know. And we are going to bias the battery in the reverse manner, where here it is like this. The N side is connected to the positive. And already we have seen in the previous video, inside the depletion region, there are only the acceptor cores and here it should be positive, and here it should be positive, and here there is a potential barrier existing, or this potential barrier can be considered as a battery or an electric field applied here. Look at the sense of this external battery and the virtual battery existing over here in this potential barrier. So this battery is having an electric field in this direction from positive to negative, and here it is like this. Look, both the electric field of this external battery and the virtual battery across this potential barrier, they are acting in the same sense. What does it mean? Actually, this external battery is aiding, it is adding to the power of the virtual battery in the depletion region actually. So just think about potential barrier is of course the thing which is not allowing the electrons or the holes to move across the junction, and we are applying a battery which is aiding the potential barrier, means there may not be a chance of the majority carriers crossing this junction in the reverse bias. And this whole thing can be understood in another manner also, children. Very simple manner, where, what is it? These are electrons. These electrons, they are attracted towards the positive terminal of the battery. And these are holes which is attracted towards the negative terminal of this battery. So what happens in this case is that this as they are attracted to the opposite sides, what happens? There is no interest for them to cross the junction. They will be moving in this side, and this holes will be moving to this side as they are attracted towards the negative terminal. So what happens is that they move farther from the junction. So what happens to the width of the depletion layer here? You just understand what happens to the depletion layer here. The depletion layer, as they are moving farther from the depletion layer, what happens is that the width of the depletion layer increases, isn't it, children? It is increasing. So what happens to the width of the depletion layer when a diode is reverse biased? When a diode is reverse biased, the width of the depletion region increases. Then what happens to the potential barrier? This was the potential barrier existing. I have already drawn it in the case of forward biasing in the last video. This is the potential barrier existing, and suppose it was some 0.7 volt or 0.2 volt existing here, normally in the case of silicon or germanium, and when we are applying a battery here, it is actually adding up to its effect, right? So what happens is that this potential barrier there increases. because this electric field is aiding this virtual battery here. Already there is a wall here, and this battery that we apply is aiding it. So what happens is that when reverse bias increases, the height of the potential barrier again increases and increases, and the height of the potential barrier increases. First it was the case like this. So what happens is that it again get added up, because no electron or hole will be now able to cross this junction. The majority carriers will not cross this junction. So what happens in a PN junction diode, in its reverse bias, there is no chance of this majority carrier crossing the junction and contributing to a current. In other words, we can say that a PN junction diode in its reverse bias does not produce a conduction by a contribution of the majority carrier. So generally we can say that a PN junction diode in its forward bias conducts well, and a PN junction diode in its reverse bias cannot conduct because the majority carriers cannot cross the junction. So now, before concluding it, we can have some application level question of from this session, PN junction diode in its forward bias and reverse bias. So let us draw 4 diagrams in which we will analyze it. So here a plus 5 volt is given and a minus 2 volt is given in one diagram. The next diagram, it is earthing here and a plus 5 volt here. And another PN junction, what happens is that here let it be a minus 5 volt and here there is a plus 5 volt, and in this diagram let it be minus 2 volt connected and let this be earthed. These are the 4 examples that I can show you, and can you analyze whether it is in a forward bias or reverse bias. For understanding this or tackling this type of question, it can be a sure question for your board examination. How can we do this? Usually what is forward biasing? It is a positive side connected to positive and negative side connected to negative. That is it. But in reverse bias, the positive side of a diode connected to the negative side of the battery and vice versa. So in this case, while analyzing this question, we have to understand this in another way. What is it? The positive side should be connected to the higher potential and the negative side should be connected to the lower potential. That is it. So how you can analyze it? Here, look, the positive side is connected to lower potential and the negative side is connected to the higher potential, isn't it? Positive to lower and negative to higher. So this diode is reverse biased. Please understand, children, this diode is reverse biased. Look at this case. What is the potential of earth? The potential of earth is 0 volt. The potential of earth is treated as 0 volt. So here look, the positive is connected to higher potential, that is plus 5, and the negative side is connected to, what is it? The lower potential. So this is forward biased. Understood, children? And in this case, what is happening? The negative side is connected to the lower potential because it is minus 5, and the positive side is connected to the higher potential because it is plus 5. In this case, it is forward biased. And what about this case, children? The negative side, here it is 0 volt and this is minus 2 volt. So the negative side is connected to a lower potential and the positive side is connected to minus 2. 0 is greater than minus 2, higher potential. So positive to higher potential and negative to lower potential. This is a forward biased diode. So a diode is forward biased when its positive side is connected to higher potential or it is connected to positive, we can tell. But in this type of diagrams or analyzing these problems, we have to understand that the positive side should be connected to higher potential and the negative side should be connected to lower potential. Look at this. This is the only case where the negative side is connected to the higher potential. So this is reverse bias. All the other cases are forward biased, and you have to understand that the earthing given here can be considered as the 0 volt. I hope that you have understood this session. In the next session, we will be dealing with a PN junction diode characteristics. Till then, bye-bye.